This is a tutorial on exponents and powers. A power expression is just an expression that has a base and an exponent. So here's an example. Here we have a base of 3 and an exponent of 5. Or we would say we have 3 to the 5th power. Now 3 to the 5th power is the same as multiplying 3 by itself 5 times. Or 3 times 3 times 3 times 3 and then times 3 the 5th time. Well, if we did 3 to the 1st power, that's only one of these 3's. So that's equal to 3. And if we did 3 to the 2nd power, that's the same as saying 3 times 3, which would be equal to 9. And then 3 to the 3rd, or 3 cubed, is 3 times 3 times 3 a 3rd time, which is 27. 3 to the 4th is 3 times itself 4 times, which would be equal to 81. So 3 to the 5th power is 3 times 3, which is 9, times 3 again, which is 27, times 3 one more time, which is 81, and then times 3 the 5th time is 243. So 3 to the 5th power is also 243. So let's practice this a couple more times. Here we have negative 4th to the 3rd power. That's the same as saying negative 4 times negative 4 times negative 4 again. Well, negative 4 times negative 4 is a positive 16. And then times negative 4 one more time is equal to a negative 64. So negative 4 to the 3rd power is a negative 64. What if we did negative 4 to the 4th power though? Well, that's negative 4 times negative 4 times negative 4 and then times negative 4 one more time. Well, negative 4 times negative 4 is 16, times negative 4 again is a negative 64, and then times 4 one more time is a positive 256. Well, notice, if you ever have a negative base, or a base that's a negative number, and your exponent is odd, you're always going to end up with a negative answer. If you have a negative base and you have an even exponent, then your answer is always going to be positive, just from the way that multiplying negative numbers consecutively works. Now let's try and do this exponent of this fraction. 1/3 to the 5th is the same as saying 1/3 times 1/3 times 1/3 again, times 1/3, and then times 1/3 one last time. Now you can actually separate the numerator and denominators. So you'd have 1 times 1 times 1 times 1 times 1, which would be equal to 1. And then 3 to the 5th, 3 times 3 times 3 times 3 times 3 is 243. So 1/3 to the 5th is equal to 1 over 243. Notice that this would be the same as saying 1 to the 5th over 3 to the 5th. So anytime you see an exponent on a fraction, you can write it like this, or you can write it like this. Our last example, we have 6 to the 3rd power. So this is 6 times 6 times 6. Well, 6 times 6 is 36, and then times 6 again is equal to 216. So 6 to the 3rd power is equal to 216. There are several geometric applications to powers and exponents. Say I decided to buy a small piece of land that was 100 feet by 100 feet, or 100 feet square. I could figure out the area of my land by multiplying 100 times 100. Or I could say it's 100 feet squared. Well, 100 times 100 is 10,000, or 100 feet squared would be 10,000 square feet. Say I had a box that was a cube, and I wanted to know the volume of my box. Well, I could take the 8 feet and multiply it by 8 feet again, and then by 8 feet again for length, height, and depth. Or I could find the volume by saying 8 feet cubed. Well, 8 times 8 is 64, and then times 8 again is 512. So the volume of my box is 8 feet cubed, or 512 cubic feet. Now lastly, let's see if we can go backwards. Here we're told that 16 is equal to some base that we don't know to the 4th power, and we're asked to find that base. Well, since we know we have to do it to the 4th power, that means we're going to need 4 numbers, or 4 of the same number, multiplied together. It's going to equal 16. Well, we can try various numbers. We can try 4. Well, 4 times 4 is 16, but that's only to the 2nd power, so we know 4 is not it. Let's try 2. If we do 2 times 2 again, and then times 2 again, this is 4 times 2 again would be 8, and then times 2 again would be 16. So that works. That means our base is 2. Or 2 to the 4th power is equal to 16. Let's try the next one. Here we're told that 81 is equal to 9, so they gave us the base, and they ask for what exponent it is. Well, we know we're going to multiply 9 by itself as many times as it takes to get to 81. So 9 times 1, or 1 9, doesn't do it. But if we take 9 times 9, that equals 81. So our exponent then is going to be 2. So what we get is 9 squared is equal to 81. And that completes the tutorial on exponents and powers.